Okay, so let's take a look at a second example, a different example. Yep, going to say period. So right now, we're going to find the area enclosed by y squared equals x squared plus 4 and y equals 2x minus, or 2 minus x. So what do those look like? Okay, so y squared equals x plus 4, that is a parabola. However, being y squared, it's a parabola though opening sideways. So I'm going to go ahead and you notice I did a few of these already, a few values here. So if x is negative 4, y squared is equal to 0, that means this here, and then the parabola is going to be open, again, because of the coefficients positive to the right. I know that when x is 0, you get y squared equals 4, so you're going to have plus or minus 2. So this parabola is opening this way. And yes, I know that is not a function, but again, we're talking curves, so whatever happens, happens. Okay, so how about the next graph? Y equals 2 minus x. It's a line. Think of this. Y-intercept is 2, slope's negative 1. That way. Okay, so there's the region right in here, what we're trying to do. So we've got all these rectangles, like that little rectangle there, that rectangle there, that rectangle there. Oh, wait a minute. Notice how this part of the curve, we go from parabola to the parabola. Now we can deal with that. We'll deal with that in a second. But over here, we're going from the line to the parabola. So we're going to have to split that up into two different integrals. One for this one over here, and then one for this one, because we have two different sets of boundaries. So, okay, so for this first one, again, this is our y values, our heights are all changes of y. So what is, think about this as an ordered pair x comma y. What is that y value? Well, that comes from the parabola. So we got to solve for y. Oh, okay, that's quick. Plus or minus square root of x plus 4. Well, being this is the positive y values, this would be the positive square root. And of course, these being negative y values, that would then be our negative square root. So for this piece right here, this region, we're going to go from our top y value, big Y value, minus little always gives us a positive value, big minus small. So big is the positive square root minus the small, the lower one, which is the negative square root. Okay, so that is the height times our width, or times our base, our little delta x. We're going to add up all those itty bitty rectangles from x equal negative 4 to 0. Now, the only reason we know for a fact that's 0, that the two graphs intersect there at 0, because from the line that's the y-intercept, we figured it out when x was 0. The y-intercept, in fact, parabola has got two y-intercepts, one positive, one negative y-intercept. Okay, now that doesn't restrict us from verifying it, which we're going to have to do. Try to figure these out. Try to figure which ones those are. Now, because we're going to have to find what that point of intersection is over here for the second piece. We'll do that in a bit. Let's look at the second integrand. So the top minus the bottom. Again, that's y value minus y value. So top y value is the line. Well, the line, the y is equal to 2 minus x minus the lower y value. Well, that's the bottom part, the negative parabola. And that's why I write this down here. So I wrote the equation of that on there, and I probably should have done that here. Y equals 2 minus x. So minus the negative square root of x plus 4. So there's your height of the rectangle times your width. Height times base. There's area. Now, so there's area of one rectangle. We're going to add them up from 0 to what? Okay. Yeah, point of intersection. So got a couple different things. If we're looking for x, we could go ahead and, well, this is already solved for y. We could use that here, but look, we're going to have to deal with an equation with a square root. However, let's solve for x in both of these cases. So in the parabola case, x is equal to y squared minus 4. In the line, x equal 2 minus y, and set those equal to. Now, granted we'll have a little different one additional step, but the solving might be a little quicker for us to deal with, because then we don't have an equation with a radical. Not that we can't do it, but we can avoid it. So the x values are going to be equal, and then therefore the y values also be equal at those points of intersection. So you got y squared minus 4 equals to 2 minus y. Add y, subtract 2. So y plus 3, y minus 2. So y is equal to negative 3, or y equals 2. Well, when y is 2, what's x? In either one, which one would it be nice, quick to solve for? Take your pick. If we use the line, 2 minus 2 is 0. Hey, that's what we already had. That's this point right up here. When y is negative 3, my guess it's this one here. What's x? So 2 minus a negative 3 is 5. And so this region, that ordered pair is actually going to be 5 comma negative 3. And so now, simplify first. Minus a negative. That gives us 2 of those square roots. And maybe this would be nicer for us. To the 1/2 power. Not much to do over here other than get rid of the minus the negative. Integrate. So 2 times, that's x plus 4 to the 3/2 times 2/3 from negative 4 to 0. 2x minus 1/2 x squared plus x plus 4 to the 3 halves. Again, 1/2 power. Divide by the new power from 0 to 5. This is, again, is the notation you should be seeing. When you take the antiderivative, you don't have the sum anymore. You've taken the sum. Now it's how we evaluate it. How we evaluate it. So 4/3, 2 times a third. 0 plus 4 to the 3 halves minus -4 plus 4 to the 3 halves. So plug in 5. Again, show the substitution. Oops, 3 halves minus, now plug in 0. Two-thirds. Not going to look the nicest. 0 plus 4 to the 3 halves. So 4 to the 3 halves. So square root of 4 cubed. 4 plus 4, or sorry, -4 plus 4. Doesn't matter what power then. So 10 minus 25 over 2 plus. Okay. 9 to the 3 halves. So 9 to the half power. Square root of 9 cubed. We're dividing by 3. So that would be 9 times 2. Then minus 0 minus 0. Be careful here. That's not 0. Cube root of 4. Sorry, square root of 4. So that's 2 cubed times 2/3. So let's see, 32 over 3 over here plus 28 minus 25 over 2 minus 16 over 3. So let's see here, we got 16 over 3 plus, this is 56 over 2 minus 25. Common denominator is 6, so that would be times 2, 32, times 3 would be 93, so 32 and 93, 125 over 6. Now, after we plugged it in, the rest of this stuff is your arithmetic. So that's here. Again, because we change boundaries from upper parabola to lower parabola, that's good. And then we change to line as the above to the lower parabola. So we have to split it into 2. Now, Monday we're going to take a look. There's a different way of looking at this, so we don't have to mess with it by splitting into 2 separate ones.